So I want to look at the brake system and its accumulators and valving, and we've got two more accumulators on this machine dedicated to the brakes. One is for rear axle braking, one is for front axle braking, because we do have a split system for safety. We've got a front and rear split. So these accumulators are going to keep oil charged as a reservoir for the brakes under pressure. So if the engine quits, we'll still have several applications of the brake pedal using stored energy from these accumulators. The pump that's going to charge up those accumulators is mounted here on the engine. You can see there's an aluminum gear pump down in here. That is our brake pump, but it is also our hydraulic fan pump. So we can't look at the brake system on this machine without looking at the hydraulically driven engine cooling fan. So there's a hydraulic motor back here driving our fan that cools the engine, the transmission, the air conditioning condenser, etc. So we have an open circuit hydrostatic system driving a fan that is fed from the same pump as what is charging our accumulators for the brakes. So brakes and fan are sharing a pump. So as you might imagine, a familiar valve we're going to run into here, if we're going to have one pump feeding engine cooling system and brakes, we're going to want a priority valve, because we're going to want to make sure that the engine cooling system doesn't rob oil, that fan system doesn't rob oil from the brakes. So in here is our accumulator charging valve mounted right at the back of the fan and brake pump. So accumulator, it's a combination accumulator charging valve and a priority valve. So it's going to do double duty. It's going to make sure that the accumulators are charged before the fan system gets full flow to the fan motor. It's also going to determine the cut-in and cut-out pressures for charging our accumulators. So much like an air compressor might kick in and charge up the air tank to a certain pressure and then kick off, and then as the pressure drops back as you use the air out of the tank, then maybe it would cut back in and fill the air tank again. That's what our accumulator charging valve is going to do for these brake accumulators. It's going to work just like a valve on an air compressing system, but much higher pressures. We're going to be charging these accumulators up to around 2000 psi. We'll see the actual spec in the manual, but that's approximate. And then as we use the brakes, that pressure will come down as we use oil out of the accumulators to feed the brake system, which we'll look at in a sec. We're going to use oil out of the accumulators, and then somewhere around maybe 12, 13, 1400 psi, this valve will index the flow out of this pump to recharge the accumulators. So this pump's going to be part-time charging up our accumulators. Every time they charge up to around 2000 psi, the accumulator charging valve is going to kick out, and then oil is going to flow to the fan motor. So what we'll see, if you're on the brakes heavy a lot on a machine like this, you'll see your engine cooling fan slowing down. So every time you're using the brakes, you'll see the fan slow down if the accumulators are being charged a lot. Once the accumulators are charged up and the accumulator charging valve cuts out, then all the flow is routed to the fan motor and the fan will speed up. So brake issues can actually cause engine overheating on a machine like this. Once you understand the system, you see they are connected. So then from these accumulators, once they're charged up, or even if they're not charged up, they're always connected as well up to the brake control valve, which is mounted under the cab. We've got pedal braking in this machine, and if I look up in here, I see a brake valve. So a foot operated valve that's going to proportion brake pressure from the accumulators down to lines to the inboard brakes in the front and rear axles. So this machine's got four-wheel braking. They're inboard brakes mounted in the axles. So inboard in here, we've got brakes built into the axle assemblies. There's lines that come down to those brakes. They're oil pressure applied brakes. So that's why we need oil stored in those accumulators, so we don't have to have the engine running all the time to be applying the brakes. We should probably get, manual may tell us how many, but we should probably get 5 or 6 applications of the brakes when the engine's off. Then we're going to have a problem if we're trying to brake over long distances without the engine and the pump filling up the brake accumulators Then we're eventually going to run out of oil and we'll have no brakes. Then we've got a cable operated parking brake in the cab. So parking brake is old-fashioned cable down to a drum brake in there on the drive line. So to check brake pressure, we've got a pressure tap on the pointing forward from the rear side of the accumulator charging and priority valve. But before I can snap that gauge on to check the pressure there, I'm going to have to get in the cab and pump the brakes down a bunch to get rid of the pressure in those accumulators, because they're going to fight me trying to snap on that quick coupler. So there's two brake pedals in this machine. They're both connected to common linkage. So pushing one brake pedal, pushing the other brake pedal does nothing different on this particular wheel loader. So I'm just going to pump that a bunch of times to get rid of the charge in the accumulators. And actually feel the pedal go a little bit soft once the accumulators are empty. So once I felt the pedal go soft, I was able to snap that quick coupler on very easily. So we've got no pressure in the brake system. What we'll do is we'll start the engine up, and what we'll see is our pressure will come up in our gauge there at the supply to the accumulators, and we'll see the pressure build until we reach the cutout setting of the accumulator charging valve, and then the brake pressure will hold at that. So I'm going to take this gauge up to the cab with me. So foot off the brake pedal, I'm just going to start up the engine and we'll watch our gauge at our supply to the brake accumulators. So right about 2000 psi, it cut out. So that's our cutout pressure. That's basically where the accumulator charging valve measured that pressure and said that's enough, and quit filling the accumulators, and then diverted the rest of the oil to the fan motor. At that point, you may have heard the engine kind of rev up a little bit, because the load comes off of the engine when the accumulators are fully charged, because the oil going to the fan isn't obviously going to be running it. It's going to be load induced by the fan, which doesn't take 2000 psi. So you do hear a little pitch change in the engine, especially with this noisy 3116. It's one of the noisiest engines in our fleet here. Now, if it's bled down slowly again through, I assume, through the brake valve. We're bleeding on some of our oil. Should be a closed center valve for braking, but again, it's metal to metal fit inside, so we're losing a little bit of pressure within the brake valve. We seem to be settling kind of at this 1770 psi. If I apply the brakes, again, this is with the engine off, so I apply the brakes, you can see every brake application. You can hear dropping. I'm using about maybe 100 psi, 70 maybe, 70 psi per application. So every time I push the pedal, let it back up until I got down to a lower pressure, and then it fell right off. So I'm going to start the engine. We'll watch it cut out again. Just keep applying the brakes. Watch our gauge. Down to about 1,900. Oh, you notice there, right? I got below 900, then all of a sudden with one application of the brake, it fell to about 20 psi. That's given me a pretty cheap and easy look at my accumulator pre-charge pressure. When I use the last tablespoon of oil out of the oil side of the piston in the accumulators, the pressure is going to fall rapidly. So I'm kind of seeing approximately there what my nitrogen pre-charge is on the other side of the piston. The more accurate way to do that is to actually hook a nitrogen pressure gauge up to the nitrogen side fitting on the accumulator But this is kind of a quick and easy way to get an idea of how much nitrogen is in your accumulator and whether or not it needs to be recharged. This machine, we usually get about 3-4 years before we have to recharge the brake accumulators and the pilot accumulator. And this one's been about 3, and it still seems to be holding about 800-900 psi of nitrogen, which I think is the spec. But we can verify that in the manual. I'm going to try that again. Now I'll be pumping the brakes with the engine running. We'll watch our cut out, and then I'll pump the brakes while the engine's running, and we'll watch our cut in pressure. So we'll see the pressure drop down, obviously not right to 19 if the engine's running. The pump's going to recharge those accumulators, and we'll watch the gauge and see cut out first, and then as I pump the brakes we'll see cut in. So there's cut out. There's cut in. Cut out. Now cut back in. Cut out. Cut in. Cut in seems to be around 1350 psi. Rather than watching the gauge, you can almost, or watching the gauge to start coming back, I really just use my ears. I can hear the engine go under load when we reach cut in, and it starts trying to charge up the accumulators again at fairly high pressure. So it seems like when we drop our brake pressure to around 1350, the accumulator charging valve is cutting in, feeding oil from the brake and fan pump to the brake accumulators until the pressure in there reaches about 2000. Then it cuts out and directs all of the flow to the fan. So if you're not on the brakes very much, you're going to get excellent engine cooling through the radiator fan. If you're operating the machine and pumping the brakes all the time, or if your accumulators are not pre-charged properly, so every brake application the accumulator charging valve is cutting in and directing oil into the accumulators, then you could start overheating the engine or transmission, hydraulic system, or the air conditioning may not perform well. Let's start it up. We'll just see how many brake applications we get approximately between cut out and cut back in. So it looks like I'm getting 5 good brake applications between cut out and cut in. So I'm still cut in. So as I start the engine, we'll keep charging back up to 2000 psi approximately. So now we're cut out. So if I start the engine now, the pressure won't climb because we're not below cut in pressure. In order for me to get to cut in, I got to pump the brakes. So if I bring it down below about 1350, and if I was down by the valve, we might even, and somebody up here pumping the pedal, we might even hear a snap as that cut-in valve actually gets spring loaded over to the other side. But now that I'm below the 1350 or so, if I start the engine, we'll climb. We're in cut in, so we'll climb back up to cut out pressure. So that's how our cut in and cut out work for a full hydraulic braking system like this. So this is not power brakes. If I don't have pressure stored feeding my brake control valve underneath the cab there, I don't have wheel braking, I don't have my service brakes. For testing the performance of the service brakes, there is also a pressure tap on the brake valve that will show you the pressure going down to the actual axles front and rear. On some machines there's 2 pressure taps. On this machine there's 1 pressure tap. because in the other pressure tap, I forget if it's front or rear, they stole for a pressure switch that operates our transmission neutralizer. So if the transmission neutralizer is on, which is this switch down, then if I've got the transmission in forward or reverse and I apply the brakes and I get to the threshold of that pressure switch in the line down to the service brakes, the transmission will shift to neutral. And the reason for that is so the operator can, every time they touch the brakes, they can get full 100% engine power to the hydraulics by putting the transmission in neutral. If they're loading with the front bucket, they're not trying to drive through the brakes. If you want to try and drive through the brakes, then you can turn the transmission neutralizer override switch on. And that's a tricky thing to explain to an operator because it's not a transmission neutralizer switch, it's an override switch. So you're not turning the transmission neutralizer on, you're actually turning it off by turning the override of it on. But if I put the neutralizer override on, then I can actually do a torque stall, 1 foot on the brake and 1 foot on the throttle, and we can try and drive through the powertrain. But if the neutralizer switch is off, then every time I touch the brakes I go into neutral. And if you want to try and test the brakes for performance as well, we can put it in third forward, turn the transmission neutralizer override on, and try and do a converter stall in third, and the brakes should hold at full RPM. If I shift manually down to first, then the machine should drive through the service brakes with application of full throttle. The trick there is there's another switch we have to know about, because if I go into third but I'm in automatic shifting based on ground speed, even though it says 3, I'm going to be in first gear because I've got no ground speed. So I've got to turn my auto shift off, which it was. So if auto shifting is off, then I'm literally just manually selecting between my 4 gear ranges here. But if I've got auto shift on, then I've got an automatic transmission. And based on ground speed, this machine's going to downshift from the setting to an actual gear that's lower. So if I set this to third and I have no ground speed and I'm in auto shift, then the transmission is going to automatically downshift to first. If I'm expecting the brakes to hold in third while I'm doing a torque stall, and I got my auto shift on, I'm actually going to be in first. And there's no actual gear indicator on this machine to tell you really what the transmission gear is, literally, like some machines. So we've got to understand, to do something like a stall test and performance test of brakes, we have to understand the transmission neutralizer override, and we have to understand the auto shift switch. And then I also have to understand that there's a switch in the parking brake that when the parking brake is applied, the transmission is going to be in neutral as well. So if I want to do a stall test of the brakes, I've got to make sure the parking brake is released. I'm going to apply the service brake, got to make sure my transmission neutralizer override switch is on, so we're not neutralizing the transmission with the brake pedal. I'm going to go into third forward, I'm going to make sure my auto shift switch is off, and then I'm good to do a stall test of the brakes. So we're in third. So the brakes are performing well. I can do a full throttle shift from neutral to third forward, and the machine's not going anywhere. If I try that in first, we should drive through the brakes. We should have enough engine power. So you might have been expecting some more dramatic driving through the brakes, but you may have noticed that we were creeping forward there. That is the criteria to pass that test. So this machine has passed the operational test of the service brakes. If I want to test the parking brake, then I got to apply the parking brake, but we know that neutralizes the transmission. So to test the parking brake, I've got to go third forward, then I've got to go into forward, then back to neutral, then back to forward again within 3 seconds. to override the transmission control's sensing of the parking brake being applied. So you could do that same test for the parking brake as well. Again, that may be different with other manufacturers. Caterpillar says that their machines should be able to drive through fully applied service brakes in first gear. They should be able to hold a full throttle torque stall in third, and same rules apply for the parking brake. And the logic there for saying that we should be able to drive through the brakes in first is just if the brakes for some reason got stuck on, whether you can hear how rusty our linkage is. If the pedal ever stuck to the floor and you were in some hazardous location, at a railway crossing or something, for example, they want to make sure that you've got enough power to drive the machine and move it. Now, you're not going to get very far very fast, but this machine will move. And same with the parking brake. If the parking brake's on, we go into third, we go forward, back to neutral, back to forward. It'll override the parking brake, neutralizing through the parking brake switch, and then we'll be able to drive through the parking brake in first gear as well if everything's working well and we've got lots of engine power. So it's first and third. Second is gray area. They don't give a spec for second. I find this machine, when it's got summer fuel in it, will usually drive through the brakes in second. On winter fuel it won't, but that's not part of the test anyways. First, it should drive through the brakes. Third, the brakes should hold a full torque stall.